DSE experiment 4. Today going to see the first question. The sample mean of price when n is equal to 40 repeated 3 times per fuel. The goal is to demonstrate the concept of the sampling variability, and the central limitation theorem shows how the sample means vary around the true mean, and we want to show that how the code works. Explanation. We took 3 different random samples of 40 cores of each. We can see it here, and the each sample choose slightly different means due to a sampling variation of CNG through the expectation message, because it has a fewer than the 40 data in the total. We can see it here clearly. The sample 1 mean, sample 2 mean, and the fuel type is petrol, the fuel type is diesel, and the fuel type is CNG. Not enough. Why the CNG is not calculated is CNG they have not enough data. The second question is sample mean for the price versus price. N is equal to 80 versus n is equal to 40. The goal is to show the effect on the simple size, on the estimation precision, raw of large numbers. How the code works is that it draws a smaller number of sample n. We can see here it draws a smaller number of sample n, and the largest sample is 80. From the same fuel category, compares their mean. As the size increases from 40 to 80, the standard errors decreases, making the sample mean n is equal to 80 a closer and more stable estimation of a true popular mean. And the third question is the population mean for a price per the fuel. First, the third question goal is to calculate a true parameter population mean for each category in the entire disk. How the code works is a group by fuel type and the price dot mean to compute the overall average price across the record for DNG. This means what I will take this one and this one. Okay, and this will calculate the average of the CNG, diesel, and the petrol. The sim dot statics pop dot means it will take outside the elements, delete the element. And the third question, and the fourth question here. The fourth question is the confident interval n is equal to 40. The goal is to construct an interval estimation of a population mean and check whether the true mean falls within it. And how the code works, it takes the sample of 40, compute the standard error, means the sim is equal to s divided by root of n is a formula with which this formula inside the function is the stat.sim, and uses the student t is equal to distribution, and the interval stat.t.interval df is equal to 39. Is a confidence level 95%. We can see 95%. And the fifth question is that fifth question is that 99% of CL versus 95% of CA with comparison. We want to compare that with. The goal is to understand the trade-off between the confidence level and the precision. How the code works, it calculates both 95% and the 99% of the interval, and the sample space is equal to n is equal to 40, and calculate therewith. The main formula used is the upper bound minus lower bound is a formula. The higher confidence level 99 requires a larger critical t value, which makes the confidence interval wider. The diesel width increases from 3738 to 5004. We can see in that higher certainty cost per precision. And we go to sixth question. We can see the plot here directly. The goal is to visually demonstrate what 95% of confidence interval truly means across a multiple repeated sample. How the code works is that it simulates 25 independent samples of size 40 and a petrol cost compute of 95% of CL for each plot intervals as a horizontal blue line. The plot is a true population means a vertical dashed red line. You can see the vertical red line, not blue line. You can see the blue line. By plotting the 25 independent interval, we show the approximately 95% in our run 25/25 of the interval captured in the two red population mean in the line. We can see here. And the seventh question. The goal of the seventh question is that to measure the strength and the direction of a linear relationship between car age and the price. However, how the code works is that it calculates a presence correlation coefficient using stats.presenter. prisoner for each fuel type. Okay, stat dot prisoner. We use stat dot prisoner. This here, you can see here. Check have a look on that. And the prisoner is done, meaning that the strong inverse linear relationship as the age of the car increases, its selling. If the age of a car increases, the selling price of the price will decrease. Indicates. Okay. For eighth question, the goal is that to measure the monotonic relationship using rank between the kilometers driven and the price and compare it with the prisoners. Okay, very easy question. How the code works is uses stat dot spearman and stat dot prisoners between km and the price. Okay, and Spearman evaluates a monotonic association without assuming a strict linearity. Both Spearman and a person's value are negative, showing their higher mileage consistently led to the lower car validation. Okay, I can go to the ninth question. The ninth question is a very easy question, converted matrix. The goal of the ninth question is to determine the directional joint variability between all the numeric features. Example, the price, age, km, ph, cc, weight you can see here. How the code works is execute data.curve on the selected column for each fuel group. It means, what is that means? A diagonal element show a variance of each variable, while of the off diagonal element shows a convenience negative variable between the price. Age km indicates an inverse relationship, whereas a positive value between price and weight hp shows the heavier, more powerful cars having more powerful cars, more price. Simple. We can see the output here. And the tenth question is that z test. One sample z at high. The another name of z test is, we can tell, is the hypothesis testing. The goal of the 10th question is test the specific claim regarding population mean price and the population standard deviation is known. Okay, for that the hypothesis is equal to 12,000 average price. H1 is an alternative. When H1 is greater than 12,000, right tail test, average price is greater than 12,000. Calculation, a simple calculation, z is equal to, I will tell my own calculation, z is equal to 12,750 minus 12,000 divided by 2,500 divided by root 50, and the answer will be in p minus value is equal to 1 minus theta 2.2113 is equal to 0. Explain, since the p value is 0.0169 is less than our significant level, a is equal to 0.05, we reject the null hypothesis h0. We reject it. There is a statically significant deviation to conclude the mean price is greater than 12,000. Yes, thank you.